Bonjour à tous, merci beaucoup pour votre venue. Kind of. Thank you everybody for coming here to this presentation about Micronaut. My name is Álvaro Sánchez. I'm coming from Madrid. I'm a developer in the Java ecosystem, since Java Spring ecosystem, since a few years ago. At the moment, I'm working in a company called OCI, Object Computing. OCI is the company behind Groovy, Grails, and Micronaut. And I like to speak at conferences about microservices, authentication, Groovy, things like that. You have my Twitter handle at the bottom, in case you want to say something positive, only positive things, please. Before we get to the subject, how many of you are using Spring Boot? And how many of you like Spring Boot? Fair enough. I do as well. How many of you have heard about Micronaut already? Just more than the name itself. OK, quite a few. Is there anybody actually using it for anything? Not yet. I hope you will raise your hand after this presentation. So I will explain you why and how we came here with this framework. And I will tell you about the reality of the existing frameworks. And I will mention a lot Spring because it's the most used Java framework everywhere, but it also applies to others like MicroProfile or Jakarta EE. And the issue they have is that anything based on reflection or annotation based on reflection tends to become fat. However, we really love the productivity model, not the productivity model, the programming model. So we like to have DI, dependency injection. We like to have the services controller programming model. So we live with it. But can we be more efficient in terms of a Java framework? So if you think about the Spring, which is like 15 years old already, it is an amazing technical achievement. It literally changed my life as a developer, and probably yours as well. Before Spring, everything was much more complicated. Everything was worse. But the only problem I see with Spring is the many things they do at runtime. Like, for instance, they not only have to read your source code, but at runtime they need to read your bytecode. Every single class, every single for every single bean, they need to read all the annotations. They need to synthesize all the annotations to support annotation metadata using reflection. And because reflection is so expensive to use at runtime, they need to cache that reflective metadata. And caching that information takes memory. So it's essentially the time it takes to start up the application and the memory consumption is a function of the size of your code. The more beans you have in your class path, the longer it takes to start, the more memory it consumes. So Micronaut is a new framework created by the team who created Grails. So you know Grails? Yes? Anybody used Grails, actually? 2 people, OK. But at least you guys know about Grails. So Grails is a 10-year-old web framework based on the Spring and Hibernate. And over those 10 years, we've learned quite a few lessons about how to create a framework, right? So based on the previous analysis, we decided to start from scratch and create something new. And that new thing is Micronaut. The design goals of Micronaut are essentially to have the productivity of Spring Boot, because we like it, but with the performance of a compile-time non-blocking framework. Micronaut is designed with the cloud in mind. We support already many of the 12-factor patterns, like service discovery, distributed configuration, stuff like that. So it's really designed with microservices and the cloud in mind. It is really lightweight for several reasons. One is because it is based on Netty instead of Tomcat. So Netty itself is really fast. And the other one is that the internals are reactive. We use RxJava internally in the framework. So in terms of the features, you can think of it as a combination of Spring Boot plus Spring Cloud plus Spring Security, right? So that is more or less, it's not a one-by-one feature comparison, but just for you to get an idea. The approach we follow, or why is Micronaut faster? Because AOT, ahead of time compilation. The idea of AOT is that we use annotation processors to pre-compute all the framework infrastructure at compile time. So we don't do anything or very little at runtime. Like for instance, all the dependency injection, configuration properties, conditional bin definitions, everything is read and processed at compile time. And we introduce new classes along with your classes at compile time, as opposed to use runtime proxies. So with Micronaut, you can build, obviously, microservices. It is really suitable for serverless applications because of the startup time and the memory consumption. If I have time, I will do a Google Cloud Run demo. We do support AWS Lambda as well. You can build message-driven applications with Kafka Rabbit. We have, in the Spring Boot world, they call it starters. We have the same notion called configurations. And we have configurations for many things, like Kafka Rabbit, MongoDB, Postgres, GraphQL, Neo4j, right? So the most used technologies are already usable. You can use it for CLI applications. Not everything has to have an HTTP server. It's usable on Android. So if anyone has done any Android development, you may know about Google Dagger. Dagger is actually a good influence for us because they built dependency injection framework at compile time, right? So, but Dagger is literally just dependency injection. In Android, you can use Micronaut for not only for dependency injection, but also for configuration, for the HTTP client, anything like that you can use it for. Or essentially anything which has a main method. And now you may have heard of Growl VM. Have you? Raise your hands if you have. Yes, it's like what everybody wants to integrate with. So Growl VM is a new polyglot universal virtual machine from Oracle. It's, under the name Growl VM, there's actually several things, like the substrate VM and the native image. But most of the time, what people refer to is the native image feature of Growl VM. And that enables you to create native code, which runs much faster. So the idea is that you can turn a Java application into native image using ahead-of-time compilation. So you can see the fit between the two projects are really natural. So that is a screenshot of a Micronaut Hello World application running in 14 milliseconds, which is really fast. Braille VM is promising a project to keep an eye on, but it's still experimental, right? So it's probably not for today or not for everybody or for all the kind of projects, but it's something to keep an eye for the future. We optimize for Braille VM already because we want to get the best support for Braille VM. But we also optimize for regular Java, which is what people use today, right? So it's not our only focus. Any questions so far? We can leave them for the, yes, there is one.
What's the difference between Quarkus and Micronaut?
Sorry, what is the difference?
Yeah, the advantage between Quarkus.
Quarkus, yes. The question is, what is the difference between Quarkus and Micronaut? I haven't read much about Quarkus. I know, obviously, it exists. It's got a lot of marketing. They also have an integration with Growl VM. And I would say it's a similar idea. It's probably, I think the approach is different because they don't do a lot of AOT. And what they have done, as far as I can tell, is, for instance, for persistence, they have figured out the way to use frameworks which heavily rely on reflection, like Hibernate, to be usable in Growl VM. So there is actually the possibility that the work they're doing, we can benefit from that. And actually, Spring Boot is also working on Growl VM integration, right? So I think it's just another alternative. I wouldn't be able to, to compare them one by one. It's obviously having a much bigger company behind it, so you will hear about it. Okay, we may have some more questions after all. So let's do some coding. As of yesterday, there is one key in my Mac keyboard that doesn't work. Is the H key. So I don't know how this will go, but I'm sure you will forgive me for this. So a Micronaut project is a regular Java-based application. For build tools, you can use Maven or Gradle. For languages, we support Java, Kotlin, and Groovy. And we provide a CLI to get started with a new project, like to create the skeleton of a new application. It's a similar idea to the Spring initializer, but it's just that it's not a web application, but a CLI tool. I've got the project already created, and you can see there is only one class, an application class. I'm sure you've seen something like this before, right? So we have embraced many concepts and terms from the Spring ecosystem because it's what people are used to. So we didn't want the people to learn new terms, new things, new ways of running the application. So this is runnable from the IDE because it's literally a main method. It's doing anything else. The demo I'm going to do actually is using Consul for service discovery, right? So I'm going to create here creating class. And create all the Java ceremony. Actually, I want the default constructor. And I'm going to be creating as well, what else? What could we create? Let's create a controller. So, creating controller. The annotation model is similar to JAX-RS or Spring MVC, so it's really similar. For dependency injection, we use the JavaX inject annotations, so they are the standard ones. So I want a controller on the, let's say, hello, H, hello, and then let's create an action. I'm going to create a service just to show you the dependency injection. So We use singleton for the making this class a vin in the application context, and we'll create a method like public greeting, say hello, and then don't buy a Mac. Plus name. And return this guy. And then in the controller, I want the greeting service. So I declare an attribute of type greeting service, and then generate a constructor. So in Micronaut, constructor injection is implicit. When you declare a non-default constructor, we will know that it's the only way to build your object, and will provide you the dependencies as required. So this is the @inject annotation is not required in this particular case, but both things are equivalent, right? And then let's create the action. So this is public greeting. Hello, string name, and then we're going to returning greeting service, say hello, name. So this is a get request to the name argument. Let's see if this works. Yay, works. It's a hello world. So a few things to be aware of here. Like, for instance, the @get annotation is like, for instance, the @get mapping in Spring Boot. The difference is that we don't require you to be so repetitive with the @path variable, because in Spring you will have to say @path variable, things like that. We do have those annotations when you want to have different names, but because we do everything at compile time, we actually check typos. So if I were to put a typo here, and those guys didn't match, we should see a compilation error if the demo gods are with me. Yeah, there we are. So I'm gonna be leaving the application registered in console. Where are you? I've got the console UI here. So let's see if the service registers. There we are. So now I'm going to create a new application. Oh, wait a second. Let's create a test. Do you like tests? Yes, I do as well. Yes, we still have time. Right, so for testing, you can use the unit 5 is the default. You can use the unit 4 as well, Spock, and spec if you're using Kotlin. So hello, controller test. We have an annotation called Micronaut test. What this annotation does is essentially starting a full instance of your application in a random port and turning this very class into a bin themselves, so that you can do a dependency injection in this class if you wanted to. The other thing I'm going to show you is how the HTTP client works. because I could use the raw reactive HTTP client that comes with by default, but it's a little bit low level. So I want a declarative HTTP client, which is much easier. So let's create a hello client. This is equivalent to Spring Cloud Feign, if you've seen that. Once again, the difference is that this is compile time instead of runtime. So I want a client for myself. Hence, I'm using a slash here, or I could be using a path. Actually, it needs to match the controller path. So this is hello. The other alternatives for this would be to use a service ID, which I will show you later. And I only have a single operation, which I'm going to copy from here. I hope you don't mind. This is actually an interface. And that's all I need, right? So one thing I didn't mention is that I was returning a POJO from my controller. We use Jackson internally to marshal and marshal this into JSON. And then let's go to the test. So I want hello client. And I want to inject this guy here. And we'll test hello. This is an 8 test. And then answer equals hello Devoxx client hello Devoxx. That should be it. Let's run this thing. Let's do something. I'm going to have the HTTP client to be on a trace level to see what the... I know what's going on, because this is a... yes. Need to call get message. There we are. And this is a full instance of your application running on a random port. This is a full HTTP request and response. And it all took 224 milliseconds. Awesome. Do you like it? Yes? I do as well. 20 minutes. So let's move to the other application. Oh, by the way, why don't we create a growl VM image? This would be cool. The process of creating a growl VM image is essentially you need to install the growl VM SDK. It's like a regular Java SDK, JDK. And then there is a native image command line tool to create the image for you. We provide, when you create the application and you specify you want to have the growl native image feature, we provide you with a build file. It's a Docker-based process to generate the image, so that you don't have to install the growl VM SDK. This takes like 5 minutes, something like that, because the growl VM image generation takes a while. So to save you some time, I've got a pre-generated image somewhere around here. So this is the command line thing, and actually I'm gonna be spinning 2 instances of it. Let's see in console what we have. There we go, 2 instances. This one took 52 milliseconds to start, including console registration. Not too bad. Okay. All you see there is actually because I've got the tracing login level for the HTTP client. You see all the health checks between the application and console. We take care of that. So let's leave that running and create a gateway application. This is simply an application that will connect to the other one and make a request. But I want to show you a little bit of reactive programming, how things can run in parallel in a non-blocking way, to have a service discovery with service IDs, etc. So, where are you? I think I minimized the thing. There we go. So let's create a Hello Galaxy client. This is going to be an interface, and this is going to be a net client with service ID. We need to use the service ID Hello Galaxy, which is the one registered in console, right? And then I'm going to be copying the greeting class, because I'm a lazy person. So this is I'm using a single. Single is one of the reactive types from RX Java 2. You can think of them as like promises, kind of. I wouldn't go into too much details about reactive programming because it's a whole new world of things to learn. But it's just a hint for you that this client is asynchronous, or is non-blocking, to be more precise. This is Hello Galaxy, and here I need to enter the whole path. So this is hello, and then name. And let's create a controller. Gateway controller. And then the dependency, Hello Galaxy client, constructor thing, and then the action. And the action, I'm going to be using a flow bubble. A flow bubble of a greeting. This is a get on the slash. And then, listen, what we're going to do. We're going to be calling client hello with this method is no longer returning the final operation. So the client I wrote in the first application was blocking because I was returning an actual object. But now I'm wrapping the response into a reactive type, which is a hint for Micronaut to run this as a non-blocking operation. Which means that I can do more things in parallel. Like, for instance, I can do, I can use merge with another call. And return this guy here. Merge with will create, so a single is a reactive operation that returns a single element. You also have a maybe, which can return 0 or 1. And a flowable is a reactive type that can emit 0 to n values. If you are into Spring Reactor, a flowable is like a flux, and a single or maybe is like a mono, right? That's what they are. So let's run this application. And praise to the demo gods. This application should register himself in console as well. Let's check that. There we are. And now, yeah, that's fine, 8080, okay. So let's make a request. And I shall run here. So this is the root URL. And of course, this fails. Why? The demo gods didn't like me. Let's put trace in and see what's going on. They are not, they are strings. Yes, they are strings. So, because they are strings, then this is not a flowable for greeting. So let's use string here. There we are. And if I run multiple times, there's one of the responses that may come before the other. So the one thing I wanted to show you is, do you see the thread numbers? Right? So we have two operations on an HTTP client run in a non-blocking way and actually in parallel. It's two different threads launching two different HTTP requests to a single service using service discovery for the connection. What else I want to show you? Why don't we deploy an application to Google Cloud Run? You know Google Cloud Run? Google Cloud Run is a new service from the extensive Google Cloud offering. It is essentially Knative on the cloud. So it's a serverless approach based on containers. It's like Amazon Lambda, but in my opinion, much better, or much easier for you. I have another application here. Sorry, I don't know how to make the font bigger. But this is simply a hello world, right? Returning a message. So we can deploy this on Google Cloud Run. So what this is doing is using the Gradle zip plugin. The Gradle zip plugin will create a Docker image for your project automatically and push it to Google Cloud Registry repository. And after that, I'm using the gcloud CLI to do the deployment. This may take some seconds. There we are. But in case we want to make a change, we can see how fast it is to get from code to the cloud. So instead of hello, which is British, let's see, bonjour. I save the file, run my redeploy script that will regenerate the Docker image, and will use the gcloud CLI to push it to the cloud. Google Cloud Run is awesome because it is serverless based on containers. So the first request will spin an instance of your container. You don't have to worry about whether it's running on a Kubernetes cluster or not, or how many instances are behind it. You don't care. They can actually auto-scale it. And then they will give like a grace period after which, if there is no requests coming in, they will shut down the instance, so you don't pay anything. This is the first request. There is another demo I could have done, which is using Growl VM. So I could have used a Google Cloud build to build a Growl VM image, but that takes a lot of time to do it. So, but if you do that, you have a container image which starts much faster than the one you see here. Now the subsequent requests take less time, almost immediate. Awesome, it worked. So a few things to wrap up. Micronaut is an open source project. It was first announced 1 year ago. It was open source in May 2018. So it's but it was like when we open sourced it, there were 2 years of development already behind the scenes. So we've put a lot of effort. So it is an open source project based on an Apache license. There is commercial support from OCI if people need that. There has a lot of contributors, many stars on GitHub, etc. Some useful links for you. The website is micronaut.io. We have extensive documentation at docs.micronaut.io. If you were to print that, you will get more than 400 pages in a book. We have something like 50 different guides on many things, like, for instance, how to send emails with Micronaut, how to connect to MongoDB in a reactive way, how to secure an endpoint with JWT. Many guides, more than 50. There is a workshop, which I delivered yesterday here. It's a 3-hour workshop to work a little bit more than what I did here, and with a couple of microservices, MongoDB, console, etc. A lot of tests. And we have a Gitter channel if you want to reach out or have any question or want to say anything. If you like this talk, please rate me, subscribe to my channel. No, I don't have any channel. But please rate me, say cool things. If you didn't like it, say it anyway. It's going to be valuable for me. And thank you very much for your time. Merci beaucoup. And let's have questions. Questions? We have 4 minutes left to go. Yeah, so the question is how to use a database interaction, right? So we support Hibernate with JPA. And for instance, in that case, you can just simply inject the entity manager. You can use the dependency injection to, there is a few configuration values for you to configure the entity manager, and then you can simply inject it. And from there is a regular, and for instance, we do scan for JPA annotations. The other option is to use GORM, which is the ORM from Grails, but now is a new separate project, so it can be used in any kind of applications. But to use GORM, you need to define your entities in Groovy. We are working on a GORM version for Java, which would be equivalent of a Spring data, right? So it'll be the same idea of having interfaces with repositories, and then we will generate all the queries behind it. And that's due this year, probably before or after summer. Those are the options. Any other question? Properties management, yes. So for configuration, yes. You can have, I didn't show you, but I can. By default, you have a YAML file. You can have a YAML file, a properties file, a Groovy file as well. And you can override those values from environment variables, from JVM parameters. So it works the same as in Spring. You can also define configuration properties to map your configuration values to type-safe configuration values. What else? We use a Vim validation API. But we actually implemented our own Vim validation API, which is compile time, unlike the Hibernate validator, which is reflection-based. So you can declare constraints on your or anything. Like, for instance, you can say, I could say the name parameter is non-null, or for integers you can say min, max, or all the Vim validation API constraints. Yes, and all the configuration property classes are injectable anywhere. So it's like in Spring. You can use the add value annotation, like in Spring, to inject a single value. So yeah, that's if you use that in Spring, you'll feel like at home. Compile time. Yes. Yes. An external property file. So the value actually is resolved when the application is run, the actual value. But we create the hooks previously. So we enable, we generate the necessary code so that you can set those values into the application. But the actual value of the property is read from the application when the application starts. More questions? No, we have 26 seconds. I'm kidding.